Good evening, everyone. I welcome you all in today's webinar on Segmentation 101, Mastering All the Essential Tools in Synopsys Simpleware Software. Whether you are academician, clinician, or um, any student also, you can, uh, after this session, you can easily understand how segmentation is done and how you can visualize any 3D DICOM images with the help of this Synopsys Simpleware software, and how it can be helpful in either you're planning for uh, preclinical surgeries and research purposes also. So it can help you in that. So without wasting any time, I'm sharing my screen. I hope my screen is visible to everyone. So let's start with the PPT. Segmentation 101, Mastering the Essential Tools in Synopsys Simpleware Software. So what do you understand by segmentation 101 or simple segmentation? Uh, Whenever you import any DICOM images in any 3D image segmentation software, firstly, it will basically like imported as a volume rendering, or you can visualize it in 2D also as well as in 3D it as a volume rendering. After some like grayscale adjustment, you will see a mask, but it will consist of all the segments, or you can say all the anatomical structures consist in that anatomical part. So if we talk about pelvis, so it has right hip, left hip, right femur, left femur, sacrum. So whenever you want to study each and every part of a specific anatomical structure, you need to segment that. So after segmenting, you will get a proper and basically very clean segmented data. After that, you can do preclinical research, or you can plan surgeries also. And there are many things and capabilities given by Synopsys Simpleware software. So let's begin with what exactly a Synopsys Simpleware uh, is, and what are its capabilities, how do it work, and everything. So as you can see, this is its basically interface of visualization. This is a 3D model you are seeing. This is a 2D image, and this is example of craniomaxillofacial. So basically, Synopsys Simpleware software is 3D image processing and image segmentation software by which you can turn your DICOM images, DICON images, or variety of raw images into a 3D model. You can do meshing, you can do analysis, as well as you can do biomechanical properties also. So these are the capabilities of Synopsys Simpleware software. After that, you can export it into various, if you are doing meshing, you can export it to various meshing or like solvers. And if you are working on 3D printing, so you can actually export high quality STL stereolithography uh, formats from this Synopsys Simpleware software. Moving forward to its clinical application, first we are talking about orthopedics. So in orthopedics, it generates accurate anatomical models of bones, ligaments, and soft tissues also, uh, cartilages, and it covers entire part of human anatomical structures. For example, if we working on pelvis, and if you are working on knee, so it works both in CT scan and MRI scans. So when we are working on any uh, pelvis part, pelvis data, or if you are working on uh, heart also, so that we'll discuss further. Moving forward to project design and analysis. So it also has applications in biomechanics and consumer products. For example, if we are designing any protective gears, sports equipments, or anything related to basically ergonomics models. So if we are designing that also, so it will basically help you design safer biomechanical products as well as comfortable. Moving forward to physiological flows. So in cardiovascular applications, it has physiological flows capabilities. You can study their blood flow, you can study air flow, you can also study fluid dynamics with the help of its physiological flows or cardiovascular applications. Moving forward to electromagnetics and neuromodulation. So, when we are talking about any, uh, like if you are working on wearable sensors or something, so it helps in basically when we work on tissue. So we can study how electromagnetics is interfering with tissues and other parts of human anatomy, and we can simulate also. Next, we have medical design, research and development. So, so when we have uh, like any implant prosthetics, so we can directly, without any physical equipments or without any physical prototype, we can directly integrate. For example, if we talk about any uh, SW cup, so we can directly visualize, we can directly integrate it with our image data set. That is, if you want to integrate it with hip, right? So we can do it visually, and we don't need physical prototypes. So it basically reduce a lot of laborious process. Next, we have 3D printing and preparation. So when we when we go for 3D printing of any anatomical model or any structure you have segmented here, so you can generate high quality stereolithography formats out of it, and after that, whenever you process it further for 3D printing, it will like it will be very high quality. So moving forward to what you will learn in this session. So you will learn end-to-end workflow from importing the DICOM images or your particular data set. After that, we'll pre-process it, and after that, we'll see how basically we can uh, segment that data, and we can uh, use it for any specific application, or if we are using for biomechanics, if we are working on implant design, so we can do that very efficiently. Next, we can see how segmentation and reconstruction is done. So after importing, we can work on reconstruction, or as well as uh, when I talk about reconstruction, so it has a smart paint feature available. So what the tool does, so whenever any specific area of our interest is not visible in our data set, so we can like paint it with that smart paint feature. So we can do the reconstruction from there, we can do the segmentation. So it has manual, semi automatic and automatic uh, segmentation process. So in manual we use threshold, and after that we split the regions. And when we talk about semi-automated, we can use O2 segmentation, and it works on the watershed algorithms. So basically, after this segmentation, we can basically export it to 3D printing. We can do analysis. We can do a lot of things out of it. And after that model preparation, we can use it for like clinical purposes to do some research. We can basically use it for implant design, surgical planning. And you can also check when we are working on mesh generation, we can also check the segmentation quality and all of that. When we are working on finite element analysis, we can easily check its segmentation quality, and if any issues are there, we can fix it in single clicks. And after that, we'll see what we can do further in simple way. Like we can do, we can see medical device development and its applications, and like prosthetics and all, and how it can help in personalized healthcare innovation. Moving forward to the essential tools that I was talking about. So it has variety of tools available for the ease of the person using this software. Firstly, we have this importing capability here, in which we have capability to import DICOM images, raw images, SQL files, and a variety of formats we can upload. And after importing, we can basically see its uh, all the project information there. We can see how many series are there. We can see how many slices are there, how many series are there, and we can usually select any series and work on that. Depends upon the contrast and area of we want to work. And after that, we can move forward to pre-processing. In pre-processing, we have this tools available. For example, we have resample tool, crop tool, transform tools, rescale, shrink wrap, as well as pad, align, register data sets, and additional tool. We'll see it in live demonstration after this presentation. Next, we have segmentation. As I've discussed, it has manual, semi, and automated segmentation available, fully automated segmentation available, as well as it has external models. For example, in automated segmentations, we have ankle CT, knee CT, craniomaxillofacial, and hip CT, shoulder CT, and knee MRI also. But uh, what about other anatomical structures like ribs, or soft tissues like kidneys, etc. So we can achieve that by external models. Then we have measurements and 3D printing tools, in which we have mass similarity calculators, we have contours, we have center line creation, we have surgical cutting guide also. We have internal structure wizard, we can see internal structure of any anatomical structure. We can have this embossed text also, in which we can like directly paste the text of like what, if you're working on hip right, we can clearly write hip right on that section. And apart from that, we have also like pins and connectors options available for biomechanical use. We have this meshing and modeling option available. So if you are working on finite element, we are working on computational fluid dynamics, if you are working on knobs, so we can achieve it very efficiently from this. So it consists of usually around 8 or 9 steps for generating any model. Last, we can do the analysis of uh, our mask as well as models. So we can do three types of analysis. One is pore analysis, second is fiber analysis, third is particle analysis. So after that, we can generate its plots, and we can see how uh, it can work. After the new update, it has releases a lot of new features. For example, it has releases AI enabled bone fill filter. So I was talking about smoothing filters in segmentation. So it is a it is basically a automated filter that basically whenever your bone segment has any gaps or uh, vacant spaces inside, so it can fill without any laborious process, any bones or anything it can fill, and it will make it smooth. So we have a lot of smoothing filters also available here. After recent update, it has given us the spine CT auto segmentation in the auto segmentation of orthopedics. it has given us spine city. So we can directly, in single clicks, we can directly segment it into different parts. We have this hip revision city. So we previously had hip city, but now we have revision city also. So whenever we have any metal artifacts or metal uh, artifacts or something in our body, so we can use that hip revision city in that case. Next, we have measurements, as I've talked about mass similarity calculator. So whenever we are working on segmenting or creating mask, so it can easily generate mass similarity on the basis of dice scores. So if a dice score is 0.95 something, so it is 95% similar. Next, we have in 3D printing, we have surgical cutting guides tool. So whenever we are working on specific patient data, we can easily work on this cutting guides, and we can use this pin drill holes and editing tools. And after that, we can export that. Moving forward to the features of the Synopsys Simpleware software, we have this Scan IP, in which I've shown you the capabilities of importing. It can import variety of images, DICOM images, as well as DICOM images, raw images. So it basically like very efficiently import MRI, CT scan, micro CT scan, FibroScan. So the visualization here is very powerful and user friendly. So you can see it in the live demonstration that I will show you. Moving forward to its import and export formats. So in import formats, it has, as I've told you, DICOM, raw images, GIF, JPG, TIFF. In export formats, we have this ANSYS, Abacus, and MATLAB, etc. Moving forward to the meshing, or we can say finite element models also. So uh, we can achieve this from here. Uh, we have this finite element as well as computational fluid dynamics models available. So we can export directly to any solvers available for FECFD after creating the models. So it basically help in if you're working on FE. So it basically help in FE, basically help in stress and strain analysis, etc. Moving forward to its export formats, it has Abacus, Adina, ANSYS, LSDyna, VTK, MATLAB, various export formats available for finite element meshes. Moving forward to the NURBS, so it is non-uniform regional B lines. So we can directly export it to the CAD packages by using basically automatic path fetching, and we can use it to like convert the CAD models. And we can save the laborious time, and we can easily generate high quality STL and export it to uh, CAD softwares. Moving forward to the CAD. So when I was talking about implant fitting, so we can directly like import that to basically acetabular cup. There are other implants also, so we can basically import that. So we have this capabilities available, and we have this internal structure wizard also. So see to see the latest structures inside, or any. So basically what we have to do is we have to create mask to surface. So after that we can see the internal structure wizard out of it. Moving forward to the design link, so basically integrated with SolidWorks, that use that helps users to basically integrate within uh, minutes, and with single clicks you can exactly integrate with SolidWorks, and you can use the power of both the softwares. So it reduces the hassle of importing and exporting every time. After that, we have automated solutions. So in which we have automated segmentation available of orthopedics, of cardiovascular, as well as external models. So we have this hip CT available, ankle CT, knee CT, knee MRI, CMF, craniomaxillofacial, spine, shoulder, as well as in cardiovascular. Also, we have heart CT, heart valve analysis. External models, we'll see external models also to generate uh, other different anatomical structures like ribs. Moving forward, so how it will work? So it uses basically artificial intelligence and machine learning algorithms to basically uh, like fasten the watershed algorithm process, and it quickly segment any kind of anatomical structure within few seconds, depending upon the GPU you are using, and it reduces the manual uh, processing, and anyone can work on that. We don't need require an expert to work on it. Moving forward to automate segmentation of orthopedics, in which we have, like, if you talk about hip, so it basically segment proximal femurs, pelvis, sacrum, and if we talk about knee, it can segment femur, tibia, associated cartilages, patella, and it also generated landmarks. So as you can see here, so it has pre-processing options available. So it creates landmarks also, and it uses this keep all bone fragments to, like, even if any uh, even if any artifacts available, so it can remove that and keep all the bone fragments stick to each other. After that, we have this automated solution of so what how this works. So how automated segmentation is very fast, and why it is basically feasible than manual segmentation. So whenever an expert user doing work on segmentation of a knee CT or knee MRI, so it takes it around 38 minutes and 29 seconds to complete its segmentation. And if we talk about automated segmentation, which we can achieve it in 2-3 clicks, so it can done in 2 minutes and 2 seconds. So that is how it usually uh, reduces the time and laborious processes. So if we talk about AS for cardiovascular applications, so it can basically segment out its structures like atrium, ventricles, aorta, pulmonary artery, and myocardium. So it basically helps in uh, let's talk about the defects in next. So this model I was talking about. So we can export in this type of model. So what we can see here, we can diagnose any kind of defect if we have ASD or VSD here, arterioseptal defects or ventricular septal defects. So we can diagnose it or visualize it from here. So it has many parts available. So that is how it gets connected to each other. So for a manual segmentation, an expert user takes 4 hours and 6 minutes to complete a segmentation of heart, and it takes around 1 minute and 5 seconds to segment with automated segmentation feature. That is how you can. Next, we have this recommended system requirements, in which it is recommended to have these system requirements in your PC to use this software, since it is a rendering software. Let's move forward into demonstration of Synopsys Simpleware software. So we'll see how this software works, and we'll see how uh, we can do visualization, segmentation, and model generation in live. So this is our software, SimpleVareX 2025.06 version. And it has this initial GUI available here. So it has here the project information. It is the import section. It has help and support. Here it has the ribbons available by which we can easily uh, do any kind of processes and operations. So let's import a file. I'll click on this. You can click on this file and new project also. Let's click on this DICOM images, import. Next we have to click on this scan folder. In the scan folder, so what is the path we'll use? We'll go into Windows C, then we'll go into program files, move into synopsis, or we have this synopsis simplifier, extension 5.06 version. We have this data folder in which we have a lot of examples, patient data available. So for example, if I'm using this pelvis DICOM, we'll open this, and after opening, it has shown us how many slices it has available. It has 280 slices. All the details of this image is available here, the modality and the manufacturer is CT. So we can also anonymize DICOM text, or we can also store this. So I'm just anonymizing. I'll click on finish to finish this. So after finishing, you can see the interface is like two, three, two, sorry, three 2D images and one. It is 3D viewer. So it is basically a volume rendering of the image we have imported just now. So as you can see, it has a lot of noises and artifacts available. So without wasting any time, let's work on this dataset. I'll expand this. Here we have like dataset browser in which whenever we create a model or whenever we create analysis out of it, and whenever we create mask or surface structures, so it will available here. So currently we have this DICOM images available. So what I do, I'll click on this image processing, in which we have these transform tool available. So we have this resample tool in which if we have the dataset memory in like GBs or like high dataset memory, so we can basically downsample it with increasing its sampling parameters. We can downsample it, and if we decrease its sampling parameters, we can increase its sampling, so we can upsample it with the help of that. Since our dataset is like really efficient and small amount, so we can move forward to this crop tool. So whenever we are working on our region of interest, since this is extra part and our region of interest is only this much, so we can crop it like that. We can also crop it from here. We can also crop it a little bit from here. I think that's enough. And after cropping, we can click on the supplier. After this, we have this rescale to change any like physical parameters of this image. We have this shrink wrap, in which when we want to like basically decrease its basically when we using crop, so we have manually decreased its region of interest. So when we're using the shrink wrap, it will decrease it from all the sides. And if we are using pad, so if you have heard about padding, so it will increase the region of interest uniformly from all the sides, and align if our data set is tilted or something, we can use this align to rotate it with the help of angle. So we can specify angles here. Moving forward to register datasets, I'll talk about this register datasets in a bit when we are working on implants, and we have this additional also. Now we have this smart main tool. So when we have any like since this is very clean data, so nowhere is no area is left in the medical image. So whenever we have this smart pin tool, whenever we have any area, specific area left, so we can basically draw that with the help of this 2D viewers. So for that we have to create its mask. So let's move to thresholding. So in thresholding, we have this CT presets available here. Since we are working on a bone, so I'll click on this CT preset and I'll click on this bone from 230 to 3020. It has given me lower value and upper value. For additional processing, it has given us fill cavities in the resulting mask and only give the resulting island, largest resulting island. I'll click on apply. So it has created its mask. So to visualize it, I have to click on this generate a fast preview. So as you can see, it has basically reduces all the noises and artifacts available. It has created its mask. So after that, currently it is it is only one mask and it has not segmented here to the different parts, that is right hip, left hip, sacrum, left femur, right femur. So for that we can use this split regions. And before that, if we want to remove this, since this part is not of our work, so we'll click on this 3D editing. You can use the simple editing, and since delete is selected, we'll use this lasso tool. We'll move this lasso tool like this. It will remove. It will basically disconnect this upper part to the lower part. So after that, we can use this mask flood fill. And if we are using this mask flood fill, so what it does, it will basically keep this bigger island available in the region of interest, and it will remove this smaller island. So I'll single click here. As you can see, it has removed the unwanted part from my image. Moving forward to split regions, so it has presets available for ankle, spine, heart, hip. So I'll click on this hip. So I have to draw the boundaries. Since it is using watershed algorithm to segment, so I'll just have to draw the like draw the boundaries areas. So if I'm using this hip left, I have to draw here. So for that, I have to click on this live 3D preview. If I'm using hip left, I have to draw like this, and here also, as well as I can do it here. And if I'm using hip right, I can draw it here. If I'm using let's draw it here also. If I'm using sacrum, if using femur left, so you can draw it like that. If you're using femur right, after this we have this preview option available to preview our segmented data set. So after the preview, if we are satisfied with the data set, we can basically click on apply. So after applying, we can toggle off this. We can toggle off this live 3D option. We can basically generate the fast preview. So as you can see, it is very clean data set. It has segmented. So after this, if we want to work on any specific part, so for example, if I use this dataset, so I'll click on this bone filling option, and femur right is selected, and I'll click on apply. Since manual segmentation is not as efficient as automated segmentation, we'll see how automated segmentation will do the segmentation, and like it can segment in a very less amount of time, and it will be very clean data. So as you can see, it has filled the bone, and now it is looking really clean. So we can achieve like a lot of filters from here. Moving forward to the automated segmentation, let's take an example of hard city. I'll click on this open project. Moving forward to Windows C, program files, and then synopsis, simpleware, and we have this data available here, cardiac. So I'll click on no. So we have this data available here. So let's click on this automated segmentation of hard city. So we'll click on this create landmarks. So it will create the landmarks on like specific areas. Click on apply. So it will perform the segmentation on its own without any manual interference. Or in the manual segmentation, I've used a lot of tools, like I've used Smart Paint, I've used 3D editing to cut down the noises and everything. So basically it will do all the process, all the operation on its own, and it will give me a clean data that is fully segmented and have around 9 parts, in which we have this aorta, left ventricle, right ventricle, left atrium, right atrium, pulmonary artery, etc. So we can achieve the segmentation. So as you can see, that is fast. That is how it is very efficient and fast. And you don't need to be expert to do the segmentation. And it will create the landmarks that we can use it in the measurement tool. So let's just wait for it for 2-3 seconds more. And after that, we'll see how. So it has given me the summary that it is like basically find out this mask and this identified landmarks also. So it has given me this message here. So after my segmentation, I just have to click on this, generate a fast preview. So as you can see, that is how efficiently it has generated me a hard CT data. So if we want to work on a specific part of this, so for example, if you want to work on aorta, so let's isolate this specific structure here. And after isolating, we can go into measurements. So for example, if I want to create center lines out of it, so I just have to click on this create center lines, and I will click on this create. Since active mask is selected aorta and everything else is basically hidden, so I'll click on this create. So it is done very less time. So that is how you can create center lines. You can also see the cross sectional measurements here. So as you can see here, it is showing all the cross section areas. So after that, if you want to see basically the internal structure wizard, so you have to create it surface. So from here you can create it to mask to surface, or try select it, create surface. So it has generated a surface out of it, and using internal structure wizard. So as you can see here, you can see select all the modifications. You can change the shell value, minimal shell thickness, coarseness value you can change. Then you can see all the fine cavities also. And if you want to do any modifications, you can directly do the internal struct wizard. After that, if we go on this view option and enable this, so basically you can see its internal structure from here. So as you can see, since this mask is available here, so as you can see, the internal structure is nicely visible here. As well as you can also, for example, let's take again that pelvis example. Synopsis simple here, data pelvis. So after taking this example, I'm just directly going to auto segmentation of hip city. I'll click on this, keep all the bone fragments, and then I'll click on apply. So what we'll see here, we can use a lot of biomechanics operations we can do here. We can use emboss text, we can use connectors here, we can uh, also see variety of measurement tools that it has given us. And after that we can uh, basically export it to if you want to export it to a CD, we can export that also. We can uh, directly take x-ray anytime. So let's just wait for it. And after that we can also see external models, where we can basically see any anatomical structures that is not available in the auto segmentation. We have this ribs available here, we have uh, kidneys available, we have, so it has done mostly. So it will give me a summary out of it, then we'll move forward. Currently it has data set memory of 68.57 MB, and after the segmentation it will go up to around 500 MB something. Okay, so it has 239 MB. So it is generated mask, so it has identified hip left, hip right, and whatever I have done in manual segmentation, it has done in uh, fully automated segmentation, but very efficiently and very fastly. It has generated all the landmarks here: coccyx, femur heads, posterior, superior spines. So what I'll do here, I'll just click on this, generate a fast preview. So that is how efficient it has generated me the segment. And after that, for example, if I want to work on this hip right, so I'll click on this isolate. So let's see. So we can also use we can export the scene directly to the disk here in this .3mf formats. We can use these connectors also. So for example, we are using this. Click on this and connect to specific areas. And we can also use this embossed text here. So for example, it is hip right. So I can click on this. The size I'm using is around 7. So as you can see, that is how you can easily emboss any text here. I think that is fine. So this is fine. Now I'll click on apply. Okay, so for it I have to basically convert it to surface. So after generating a surface, I'll just do the same 7 and this. So now it is fine. So I'll click on apply. So as you can see, it has basically generated or embossed the text on this hip right bone. After this, for example, 3, 3. So let's deboss it. Oh, so let's remove it from here. So after this, we can use this and drag and drop this hip right mask to model. So it has given me 4 types of model generation. So first is surface model, second is finite element, third is computational fluid dynamics, fourth one is Knox one. So for now we just have to create FE model. After FE model, so it has given me the specific tool ribbon for it. So after creation, you can click on this FE model, basically setup model, and after that, since we have done the automated segmentations, so we don't have to use this smart mask smoothing from here. Since everything is fine, we can go into volume meshing. So it has given me 2 types of algorithms. First is FE grid, in which we have mixed hexahedra, tetrahedra linear, mixed hexahedra, tetrahedra quadratic, all tetrahedra linear, and all tetrahedra quadratic. And then we have given us with the FE free, in which we have this all tetrahedra linear, all tetrahedra quadratic straight edges, and all tetrahedra quadratic curved edges. So let's, for an example, we just want to take this all tetrahedra linear. After this, we'll go into this material properties. So we have to change it to grayscale based, and also from here we can choose its coarseness value. For example, if I want to make it to 30 or anything, we can do it from here, and it has more options available here. So we can also modify mesh quality. It has other options available. You can achieve it. We have material properties here, in which we can basically, a histogram is available, so we can uh, use the upper value and lower value from here, and we can do it on mass density basis, as well as Young's modulus, as well as Poisson's ratio also, as well as grayscale frequency. So we can achieve it from here also, after like putting the values. We can also use this grayscale based or homogeneous subpart material type, and we can also modify these first calibration points, and also Young's modulus. So if you want to modify it, so we can do it, and after that we can save. uh, with any name, or we can use this titanium. Then we'll go into contacts, so we can add all possible contact pairs available. In sets, we can add all the possible sets available. In the shell, we can add all the possible shells. Mesh refinement, we can add managed refinements from here. And boundary contacts, or we can select the separate and we can add the boundary contacts layers here. After this, we can close this, and we can directly go into segmentation quality. Since no segmentation issues are found, if any issues, we can directly click on this fix problems to remove all the issues. Now we just go into model preview, and after that we can go into this full model generation. So it takes around 9 steps to complete this. Till then, let's see how external modeler work. So for example, I'll take a DICOM file, I'll scan the folder here, and I'll go into downloads. I'll select a patient data from here. So it will get generated within seconds. So it has given me a lot of series available here for this data set. So for example, if I want to use this series, so similar, we have this slice preview here, we have this information here. So it is generated my finite element mesh here. So as you can see, that is how you can generate similarly for uh, surface models. You can do for conventional fluid dynamics, you can do for knobs models. And after that, if you want to do the analysis, so you can do the analysis of mask as well as you can do the analysis of models. So you can just have to click on this. So basically, I just want to create analysis of this model which I've created. So it has given me fiber analysis, particle analysis, pore analysis. So I'll click on pore analysis. After this, it has given me this setup here. So basically, I'll go in this. I'll click on model since I have created model, and I'll click on this pore size. So I'll just basically load the template here, and after that, I can, since it is out of data, I can basically run the statistics from here. Since this is our data sets, so let's move forward into external models. If I want to like segment its ribs, so what I'll do, I'll click on this total segmenter, which it has given me a lot of mask outputs available here in the modality CT, as well as it has given me the MRI option. So I'll uncheck all and I'll take all the ribs out of here. So after selecting all the ribs, just click on apply. So it will run the segmentation here. uh, till now, if anyone have any doubts in this software segmentation or visualization, processing, model generation, or we have done analysis, so we'll see how analysis can
Sir,
start.
chat.
Yes, yes, sir. Cancer cell inside while exporting it. Is it multi material? So you're talking about the in the disk. So it basically export your whole uh, data set that is that you have segmented or done the work on. So it will completely. It has house field units available. It has house fields unit that is set by you. And basically, when we work on manual segmentation, you can have the option uh, to the to like basically set the house fields unit. Since we have done automated segmentation, so it has selected automatically the house fields units. So it will be stored in that export. Yes. Analyze the bone structure and cancer cells inside it. So see, as you have seen, I have worked on this bone only, since I have this CT preset available here. So in I selected here and the threshold. So these are the house field units 232 3020. So we can surely visualize this, and if you create a model out of it, so you can basically export it to all the FE or CFD solvers available. So it has very export capabilities available. And as I've shown you the in the Surface Tools, it has internal structure wizard also. So we can basically do and achieve that from here also. So as I've done the pore analysis, so let's see. So in the statistic parts, you can sorry, okay, we have to run the analysis again. I'm using this uh, total segmented model here to segment these strips. It will take some amount of time here to basically generate the ribs, and we can also achieve further processing or filters from our image processing data region to basically generate uh, like smooth these ribs. And after this, if anyone have any specific doubt, you can directly contact me, and we can do like one-on-one Google Meet session with you with your specific data set. Let's wait for this simulation to run. So since it is completed, so we can directly click on this plot, and you can see the statistic plots here of pore analysis. Even if we do for surface area, if we use for shape factor, so we can uh, do the analysis from here. Apart from that pore analysis, it has also given us the option of fiber analysis and particle analysis. So we can generate that analysis out of our mask also, as well as models. And so it is taking a few more time. So what it will do, since I've selected on the rib part, it has a lot of part available here. So it will generate the rib structure, and basically what how segmentation done here is it uses color coded operations, and it uses watershed algorithm to separate out or to segment out these specific structures. So it has like rib right, rib left, etc, etc. So it will basically segment it on the basis of color coding, and watershed algorithm keep them apart. Apart from that, if anyone have any other doubt related to how you can achieve segmentation, or if you want to see any specific automate segmentation, so for example, let's do it for craniomaxillofacial. Let's go into data, fractured mandible, open. So it is generating me this fractured mandible here. Since it's uh, fractured from here, we can do a lot of operations, like we can do we can use connectors here. We can basically plan the surgery here itself. So since it is volume rendering, so I'll go in automate segmentation. I'll click on this CMFCT. I'll click on apply. So as you can see here, apart from the ribs, it has generated me this spine also here. Kidneys are also available. So it has generated all the soft tissues as well as bone parts in this CT that is available here. So I can basically visualize any or segment any part available in human anatomical structures with the help of this total segmenter. And we have three more models available. There is Monai model, NNUNet model, and we have this simpleware segmenter available. So it will get done within minutes. Sure, sure. Uh, recording, recording I can provide you. And if anyone have any specific doubt related to its specific data set, so you can contact me directly. We can have one-on-one session, and we can work on your data set and specifically to your specific tools. So it won't take much time since simulations are running both the windows. We can open any number of windows depending upon the GPU we are using. And if you are using any like basic tasks, we can achieve it in many windows. Since I'm doing the segmentation in both windows, it is taking some time. And we can also have this heart valve analysis to generate basically the blood flow in the heart. And I've also shown you the measurements in which we can generate center lines. We can also do 2D contours, or we can use the mass similarity calculator to generate dice scores, and from that we can analyze how similar our masks are. For example, if we have done a manual segmentation, and if we have done the fully automated segmentation for the same patient data set, so we can basically check the similarity between both the masks. So it is about to get done. So it is almost completed. It will generate like all the parts here, from teeth to the eyeballs, and all the landmarks it will generate. So it is completed. Now let's see how. So it has given me the summaries. It has generated airways. It has generated the eyeballs, canals, etc. In the landmarks also, it is generated. So I'll click on this, generate a fast preview. So as you can see, we can also remove the airways from here. If you want to work on specifically on this jaw part, you can achieve it. So I think it is also done. So let's do a generate fast preview. So as you can see, it has generated me like very efficiently. It has generated me all the ribs, segmented ribs. So from here, if I want to work on any specific part, or if I want to like, since this rib is basically, so this is the rib. If I want to uh, make it like completed, so I can use this smart paint. And achieve it from here. Okay, so active mask is not selected. So let's click on this. Which mask is this? This is right one. Okay, this is right one. So I think this is okay. So I've selected this. So if I want to like, so I can achieve it from here. Similarly from here, from any view that is feasible for you, can do the smart paint feature from here. So after that, as you can see, it has like in the size, it is like become a little bigger. So you can do similar operations to other ribs if you have like a large data set, a full human anatomy, since it is only a rib part available. So that is all from my side. If anyone have any other doubts, other queries, either you can discuss it with me in one-on-one session. I can work on your specific data set and specific tools that you want to work on. So I think no one has any doubts. So thank you so much, guys. That is all from my side. Okay. So as we know that mandible consists of two bones, cortical bone and cancellous bone. Presented these two bones in a single mode of the mandible. So basically, you're talking about the model generation. So, like, if you're working on this, so we can basically, uh, if you have if you want to work on two specific parts, so we can basically uh, drag and drop that part. So, for example, uh, this and this also. So we can generate model out of this, and it will the model will generate on both of this. We can also do multi-level auto segmentation here to generate a better preview of this. So for example, if you want to go image processing, want to multi-level auto segmentation, we generate number of masks 5. So you can achieve the multi-level auto segmentation and manual segmentation. I've shown you automated segmentation also. So you can work on any specific part. You can isolate that part and do the model generation out of it. So as it is available here, can remove the air flows from here. And from here, I can remove this muscle area also. So as you can see, it has created a mask out of it. So that is how O2 segmentation is done. It is like better in visualization than the auto segmentation that I've done here. And in this, we can clearly select how many, fix how many number of masks we want to generate. Since I've selected on 5, we can do it any number of masks. Okay.
Hello, everyone. Yeah, so there are a couple of queries regarding the student version. We don't have a direct student version, but anyways, we have an evaluation version available for Simplifier that's valid for 30 days. If you want, you can just check the evaluation synopsis Simplifier link. I'm just
Uh,
pinning it on chat box. You
hmm.
can register over there, and so that you can avail the 30 days trial of the software. There is no direct link to download the software. You need to register on the evaluation portal, and once the evaluation is approved, then you will get the download link for that. May I know you are from which institute?
I think your voice is not audible. Your voice is not audible.
Hello, I'm
Hello,
audible.
am I audible?
Yeah, may I know
May I
you are
know
from which
you are
institute?
from which institute?
No issues.
No
Anyways,
issues.
Pratik has
Anyways,
shared
Pratik
his
has
contact
shared his
details, so you
contact
can
details, so
contact
you
him,
can contact
and
him,
he will guide
and
you
he'll guide you
for the
for
evaluation
the
link.
relation link.
So, on the
So,
behalf of
on the behalf
Integrated
of
Ecosystem, I
Integrated
would like to
Microsystems,
thank
I'd
you
like to
all
thank you
for
all
joining the
for
session
joining the session
and making
and
it an
making
interactive
it
one.
an interactive one.
Thank you, everyone.
Thank you,
And
everyone. And
all those who need
all
the
those who
recorded
need the
session of
recorded
the
session of the
recorded link of the
recorded
particular
link of the
session,
particular
we will
session,
share it through
will
mail.
share it through mail.
So,
So,
thanks everyone. Thanks for
thanks
joining.
everyone. Thanks for joining.
Okay.
YouTube.